Now, what ideally should have happened here is that the next hop should not have gone to router 1. The next hop should have gone like in this direction or this direction. So let's see, why is XR1 trying to send the traffic down this way as opposed to going to the right? Okay, we need to now look at the VPN v4 update. So let's say show BGP, VPN v4 unicast for VRFA, and the prefix is 7777/32. Okay, it says that we have 2 available routes, and the best path is number 1. Okay, we received one of them from a route reflector, which is router 1. This is the best path. And then we also have a route that came from router 3. So let's see, why are we choosing one versus the other? Okay, both of them have the same metric, or excuse me, both of them have the same local preference. Then we look at the AS path is the same. Okay, they're both internal. The origin code is incomplete. Origin code is incomplete. Then the med is the same. They're both internal. Then we have the metric towards the next hop value. But why would we be preferring the, let's see, it looks like the route is not being reflected. It looks like the route is being originated by 1. So from 1's point of view, if we show BGP VPN v4 unicast for 7777/32, all, this is what the problem is. It's basically an order, it's an issue with the order that the OSPF process loaded. So originally we learned the route from router 3, and we were choosing that as the best path. Okay, so let me diagram this out. This is a real corner case situation, but this is why OSPF is such a problem when we're dealing with it as PE to CE routing. So the route came from 7 to 3, 3 sends it to 1, 1 sends it to XR1. Okay, router 1 is saying this is a route that came from 3. We're going to reflect it this way. We're going to reflect it this way. But these are the ones that have the reflected path. Okay, XR1 says I'm going to choose the one that is this. Okay, this becomes best, and now we advertise it into OSPF. Because originally from XR1's point of view, it's going to say, do I want the route that came from the client, or do I want the route that came from another reflector? At that point, the next hop was still 3, because when router 1 reflects the route, it doesn't set the next hop to itself. So in that case, we would be saying the metric to the next hop is equal because the next hop is both 3333. So this path is fails best path selection. The next one gets redistributed in. But the problem is now that when the route gets redistributed into OSPF, it's being advertised as an intra-area path, actually, or it's technically not an intra-area path, but it's an external route that is reachable via an intra-area ASBR. Now, what I mean by that is that if we look at this from router 1's point of view and show IP OSPF 1 database, it says the route is 7777. Advertising router is 7777. I need to figure out how do I reach the ASBR. Okay, the ASBR, if it was in a different area, we would have an LSA4, which is the ASBR summary. But in this case, we have that sham link, which says that 7777 is already in my area. So the end result is we say, well, the external route, from router 1's point of view, we're going to have OSPF E2 that goes this way over to XR1, and then it goes to router 3. Once router 1 learns this external route, it now advertises it into BGP. The difference here, though, is that this is not a reflected route. This is a locally originated route. So the next hop is set to itself. When XR1 gets this, it says, well, wait a minute. I have 2 routes that are via iBGP neighbors. One of them has a metric of 10 to the next hop. One of them has a metric of 20. The end result is that we choose the route through router 1, and the final end result is that there's an infinite loop in the data plane. So as someone had asked before, do we need to do a full mesh of the sham links? In this specific topology, yes, we will, because otherwise we have this, this infinite loop. Okay, the other option would be to make router 1 not a route reflector. If XR1 was not learning the path from router 1, or if router 1 was not redistributing those routes from OSPF back into BGP, then we wouldn't have this problem. But the main reason that you typically don't do this in a real design is that we're breaking the MPLS loop prevention by extending area 0 over MPLS. Okay, so let's say that we're going to fall back one step. We're going to get rid of the sham link. So on XR1, let's just roll back our last config. Let's say show config, commit, rollback. No, show config, rollback, changes, last one. Okay, so if I roll back my last one change, I'm deleting the sham link. Let's say rollback config, last one. Okay, the end result now, when we look at this from router 1's point of view, it should say that the IP route to 7777, so show IP route VRFA to 7777, is now via an external OSPF route. And let's see, it's actually going to take a minute for it to make this change because the LSA flooding needs to occur, and then they need to recalculate. And let's try tracing. Let's trace in VRFA to 7777. Now we're going 5 to 7. Oh, I forgot that we had that backdoor link between them. Okay, so now this interface here also, let's shut that down. Okay, so on router 5, we'll say on interface gig 1, 57, shut that down. Okay, now from 1's point of view, it should see this as a BGP route. Okay, it's BGP, it's coming from the VPN v4 network. It says the next hop is 3333. From XR1's point of view, it's now going to see the original route that came from 3 plus the reflected route from 1. But out of those two routes, regardless which one we take, the next hop is still router 3. So regardless of whether we chose 1's reflected route as best or the actual direct route from the client, in the data plane, we're going to be using the same label number, which is for 3333. So now when we do the trace route, let's trace in VRFA to 7777. Or let's do a ping. Ping VRFA to 7777. Let's see what 7 says. Show IP route OSPF. And this route should be coming from who? Or where was the source of the packet? The source of the packet would be show route VRFA for 7777. Well, this is kind of a bad test. Let's test it from one hop back from router 4. Ping 7777. Okay, so there's still a reachability problem. Let's see, where is it sourcing this packet from? Show IP route 7777. It says it's coming from 10411. From router 7's point of view, if we show IP route for 10411, it says the route's not in the table. Why not, though? Okay, if we go up to router 3, let's see, is it learning us as a VPN route? Show IP route for a VRFA to 10.4.11.11. It says I have this as BGP. It's internal via 11. We should be redistributing this into IGP. So if we show BGP, VPN v4, unicast, all, or actually no, let's say show IP route VRFA. We have the route here as BGP. It should have got redistributed into OSPF if we show IP OSPF to database. It is... It looks like it's not getting redistributed. Let's try this. Let's just say clear IP route VRF A star. Sometimes you'll see that the VRF table gets hung when we're making all these changes, redistributing, undoing it over and over and over. And to get the redistribution to finally occur, if you just clear the routing table, sometimes you'll see that it will refresh and it'll reinstall the route. But the problem is here now, that there it went. Okay, for some reason it wasn't actually originating the prefix. And now it is being advertised in. So now 4 should have reachability to the destination. Okay, from XR1, same thing should be true. We should be able to reach 7. And if we do a trace to this, we're going over MPLS. Okay, but now let's say that in terms of path selection, when we're looking at OSPF versus BGP, the route is coming in both directions. In terms of 7 is advertising this to 3, 3 advertises it to 1, 3 advertises it to XR1. Now, let's assume for the sake of argument that this update comes in last after the BGP update from router 1 comes in. So the update to 1 goes first, 1 redistributes this into OSPF, and at this point, the update goes around to XR1. This is an OSPF external route that has a distance of 110. The BGP update then comes in that is VPN v4 iBGP that has a distance of 200. So typically you would assume by normal routing rules that we would take the OSPF route and install that into the table because it has the lower administrative distance. Now the problem would then potentially be that if we redistribute that from OSPF back into BGP, we can cause a routing loop. Because we're going from BGP to OSPF, and then we're going back from OSPF to BGP. If someone in the core says, well, that route is reachable this direction, we could loop the traffic that way. But we should see, if you're not using a sham link, because sham link is extending the flooding domain, that OSPF will never cause a loop with L3VPN because it specifically has the loop prevention automatically encoded in the OSPF database. And from XR1's point of view, if we now look at the show IP OSPF database or show OSPF VRF A database for the external route 7777, it says that the downward bit is set, the DN bit. Okay, also we have this external route tag. If we were to look at this specific number and we take this number in decimal, convert this to hex, and then look at the last byte, which is 01. This is the BGP AS number. So basically what happens is that when we redistribute BGP into OSPF, you're tagging it 2 ways. You're sending this downward bit saying that it came from MPLS to begin with, that if you somehow receive this back in, you cannot install it in the routing table. Okay, if for some reason the down bit is not set, we still have this external route tag that says the route came from BGP AS1 to begin with, which means that we won't be able to redistribute it from OSPF back into BGP. So again, as long as you don't extend the flooding domain over MPLS, which we're doing with the sham link, then you generally don't have the possibility for a looping with OSPF because it's automatically preventing this with the encoding of the routes. Now, there is another potential problem that you could run into with this that doesn't really relate to MPLS. It's that if you have a customer router that is running the VRF-aware OSPF process, so let's say like from router 6's point of view, that if we have VRF Lite running, so let's say that we have VRF R6 that is enabled on these 2 interfaces and we're doing OSPF routing between them. So from router 6, let's go to global config. Let's say we have VRF R6, VRF definition R6, do show run interface gig1.46 and 56. Okay, we'll give this a route distinguisher. We'll say 66. And then on interface gig 1, 46, this link is now in VRF R6. Okay, same thing is true with interface gig 1.56. And we're then going to re-enable IP. Okay, so interface 46. And then interface 56. Okay, also at these link levels, we're enabling OSPF. We'll say IP OSPF 100, area 0. Will not operate until IP is configured on it. Why did IP not get enabled? The VRF's not running IP. So let's say VRF R6, address family, VRF definition R6. Address family is IPv4. Okay, then at the link level, we have this address and this one. Okay, do show run interface gig 1, 46, and 56. Okay, so now the interfaces are VRF aware. Next, we have the VRF aware OSPF process, IP OSPF 100, area 0. VRF specified does not match the existing router. Okay, let's give it a new process. Let's say 101. Okay, same with 56. Now, nothing changed in terms of the OSPF area config, so we should be able to reestablish adjacency with both router 4 and router 5. And if we now look at the show IP route for VRF R6, we see that there's a certain number of these prefixes that we're able to install the routes for. So we have the routes that are within our own area, these external routes that are within our own area, plus the intra-area routes. But notice that we no longer have routes to the other site, so the 7777 route. But if we look at the show IP OSPF 100 database, we'll see, actually 101 database, we'll see that router 6 does have these routes learned, but we're not able to install them into the routing table. Okay, this is what the loop prevention mechanism is supposed to do. It's essentially saying that these routes came from MPLS to begin with. We're setting the downward bit on them. So they went down from MPLS, from VPN v4 into OSPF. We're now saying that we are running the VRF aware OSPF process. So if we install this route into the routing table, we have the potential for a routing loop, just like we saw before between XR1 and router 1. Now, in this case, from router 6's point of view, though, it's not actually attached to MPLS, so we should be able to allow the routes to be installed without causing a loop. But the issue is that this is not the default behavior. The default behavior is that if you are running the VRF aware process, which in this case we are, okay, router OSPF 101 is in a VRF that's not the default VRF, then when we look at either the type 5 external routes or any of the inter-area routes, and we show IP OSPF 101 database for the external route 7777, it says it has the downward bit set. This means that we're not able to install it into the routing table. Now, the workaround for this would be under the OSPF process to say capability VRF Lite. Okay, the equivalence of this under iOS XR would be under the OSPF process under the address family IPv4, which is to say ignore the, no, it is to what do we call it here? It's like ignore the down bit check or something similar to that. Let's see, I'm under OSPF. Let's say under address family. No, let's say under the area 0. Let me take a look at the command reference. I can't remember what the command is offhand. So under iOS XR, let's go to, this will be under ASR 9K release 5.2 routing configuration guide. Then under OSPF, and let's search for DN. Disable DN bit check, and this is under where? This is under OSPF, under the VRF is why. I was under global. Okay, so if we were to say the VRF is A, it is then under disable DN bit check. Okay, so if you had iOS XR running VRF Lite and it was not running MPLS and you were running the OSPF process, it means that you're not going to be able to install routes that came from another MPLS site. So disable -DN bit check is the equivalent in regular iOS of capability VRF Lite. Okay, the end result of this is that even though we have the OSPF VRF aware process, when we look at the show IP route for VRF A, or actually in this case VRF R6, we should now be able to install these routes. So again, this is the default loop prevention mechanism, which is preventing when you redistribute from BGP into OSPF that the PE will never redistribute OSPF back into BGP. However, from a troubleshooting point of view, within the scope of the lab exam, they theoretically could build the L3VPN and then disable the down bit check, and this would cause a loop in OSPF. So the only case that you are allowed to disable this is if you're running VRF Lite and you're not attached to the MPLS network. If it is actually on a PE router and you disable the down bit check, you can cause a loop, and then you would have to either re-enable it or do some type of filtering in redistribution in order to stop the routes from feeding back. There's also, actually, yeah, that's an interesting question. Someone has said here, in the case of L3VPN inter-AS option A, if we're using OSPF between the ASBRs, then yes, you would have to disable the down bit check in order to allow for the inter-AS exchange. Now, we'll talk about that in later sections of the class, but this would basically be that if you were to have, let's say, AS1 on the top and then AS2 on the bottom, and we're trying to get reachability from router 10 to router 8. Okay, so let's say that this is in VRFB, this is in VRFB, and we're running OSPF. We want to run OSPF end-to-end. But on the inter-AS link, we're basically doing a back-to-back VRF exchange. So we have the VRFB here, we have VRFB here, and we're running OSPF for the routing protocol. The issue is going to be that when you redistribute from BGP into OSPF, you're setting that downward bit, and the remote PE is going to ignore those routes, not install them into the routing table, which means that you cannot redistribute them back into BGP. So yes, in that case, that would be another valid case where you could turn the check off. So on router 1, we would say capability VRF Lite. On XR1 under the VRF, we would say disable down bit check. But in our case here, when XR1 and router 1 are part of the same site, in terms of intra-AS, if we disabled the down bit on XR1 or did capability VRF Lite on router 1, then we would cause a loop between them. Now, the other thing that is more of a design issue with OSPF, not necessarily a configuration problem per se, is that the MPLS network, when we're running OSPF, counts as a hierarchy above area 0. So a couple of people had asked questions about this before. With the design that I showed, I was using OSPF area 0 everywhere. So we're essentially saying that in the middle of the network, this is what we call the super backbone. So the super backbone is a hierarchy above area 0. So area 0 is allowed to attach in that direction. However, if we were to say that between router 4 and router 6 we had area 0 here, and then between router 4 and XR1 we had area 1, this is not a supported design. So area 0 must always directly attach to the PE routers, regardless of whether this is attaching through a physical interface, so a direct Ethernet with an IP address, or whether it's attaching over a virtual link. The restriction is that area 0 has to be connected to MPLS. So the simple solution for this is that you don't put area 0 on the L3VPN sites. Like if this was area 1 everywhere, 1 here, then that's fine. Or if we were to say it is both 0 and 0, that's fine. But to say that this is 0 and 1, this is the one that's the unsupported design. So again, we will revisit this when we look at the inter-AS designs and we're using OSPF as PE to CE routing. But as you can tell, as compared to BGP or as compared to EIGRP, there's a lot of other potential ways that OSPF could go bad when you're using it for PE to CE routing. So the first thing to remember, again, is that when we did the redistribution, the external routes were not included when we went from OSPF to BGP. The other issue we saw was that on iOS XR, we don't automatically encode the domain ID from the OSPF process ID. So this means that when you're looking at multiple PE routers, you would prefer the non-iOS XR box over iOS XR, because if the domain IDs are the same, the routes would be encoded as inter-area, where iOS XR is encoding them as external. One of the other solutions for this we saw was to run the sham link. So sham link is extending the OSPF flooding domain over that point-to-point sham link. But then you open up yourself the possibility of a loop in the data plane, because you're essentially extending the OSPF flooding domain over MPLS. And if for some reason, like we saw, that if MPLS doesn't actually label switch the traffic in the correct direction, that you could cause a loop in the data plane, like we did between router 1 and XR1. Okay, there's another question. So the requirement for area 0 to be contiguous is not a requirement anymore in this case. It still is. But the issue is that the MPLS network counts as a hierarchy above area 0. So as long as area 0 is directly attached to the PE routers, then you're fine. If it's not attached to the PE routers, you need to either move area 0 or you need to configure a virtual link so that it does attach to the PEs. So what I mean by this, if we were to look at just a very quick example of this, let's say that between router 4 and XR1, we move this interface from area 0 into area 1. So on router 4, we'll say interface gig1.411 is an IP OSPF 1 area 1. And then under XR, when we show run OSPF, show run router OSPF, let's say that this interface is now in area 1. And let's actually say I need to delete area 0 first. Area 0, no interface, this. Okay, then if we show OSPF VRFA neighbors, we should see that once the neighbors come up, we will be able to form an adjacency. We'll do LSA flooding, but we won't actually be able to install the routes into the routing table. And the reason why is that router 4 is an ABR, which is not supported in this design. So what I changed it to was that we have 0 here and 1 here. While we're waiting for this, we had a couple other questions. One was, so on the PEs, if you were to change OSPF's distance to make it less preferable than IBGP, would that be enough to keep the routing loops from occurring? Yes, it would. Because the issue is that the PE router has to always prefer VPN v4 over the PE to CE protocol. Because if you're learning it from VPN v4, it means it's not part of your site, it's from a different site. Where in normal cases, it does prefer BGP over it, but if you disable loop prevention, then it's not going to work. Okay, which again would mean disabling the downbit check or doing capability of VRF Lite. Okay, so from router 4's point of view now, if we look at the show IP route OSPF, we do not have 6666 anymore. So some devices you would be able to reach, some of them not. And actually, I don't know, is 6 advertising? That's in the wrong area. Okay, let's say that this is IP OSPF 101, area 0, which is what? This is in the wrong VRF. Let's say VRF forwarding is R6. Then from 4's point of view, when we show IP route OSPF, okay, 4 is able to reach the routes, but let's see from XR1's point of view, if we show route VRF-A, we don't have the OSPF routes. So it's kind of unpredictable who will have reachability, who will not. It depends on where the break in the hierarchy is. But the issue is that when router 4 takes the routes from 0 and it generates a type 3 LSA, okay, which is the inter-area route, XR1 can't listen to that because it says no one else is allowed to be the area border router. I'm the top of the hierarchy for OSPF, so I'm the only one that is allowed to generate type 3 LSA when I'm going between the areas, which in this case the area now counts as MPLS being above area 0.